So let's look at this expression and identify what it tells us. There is a cosine outside, and I only know two formulas for cosine outside and something in parentheses. So cosine is applied to something in parentheses. Those must be what? Two not numbers, two angles, right? There is nothing else. So it's cosine alpha minus beta, or cosine, I cannot use x and y because I have x and y in the formula. So it's cosine of an angle minus another angle. So I'm going to label them as such. I'm going to say that this is alpha and this is beta. So let's write, what are we really asked to find? We're asked to find cosine alpha minus beta. But what does that mean? Which formula do I have to write? I have to write cosine alpha. That is the cosine, sine. Beta. Now careful. Exactly. That's it. So I know what I have to calculate. So now I have to determine, bless you, 4 pieces. I have to determine 1, 2, 3, 4 pieces. But I know how, because I've done this before. This is another review for the test next week. So what is this? Sine inverse x is alpha, which means that sine alpha is good. So there is a right angle with an acute angle alpha. And we know something about the sides of this triangle, if we know that sine is x. So the opposite is and the hypotenuse is 1. So then I know this side. That's it. Because it's a leg, it has to be the hypotenuse squared minus the other leg squared. So which of these do I have right now? Very good. What will I eventually replace cosine alpha by? Perfect. Excellent. What else do I have already? Good. What is it? That's it. So I already have 2 pieces out of 4. But now I have to work on the other one. So I bring that tangent inverse y equals beta. How do I proceed? Tangent beta equals y. So now this is a different right triangle with an acute angle beta. And I know something about its sides. What do I know about its sides? The opposite is if y, and the adjacent is. So therefore, the hypotenuse is. Say it again. It cannot be minus because it's the longest side, right? Plus. That's it. So now I'm going back to the puzzle. I have cosine beta. What is it?
1.
Yes? Exactly. And now I have sine beta. What does sine beta equals to? That's it. All I have to do is put everything together, and it's done. So that's why we studied this in the previous chapter, for chapter 7. But we couldn't do this in chapter 6 because we didn't know the formula for the sum and difference of angles. So can anyone dictate now from here here. Are you okay? Nico, is this okay?
Yeah, why is the adjacent one?
This one?
Yeah.
Tangent by definition is the opposite over the adjacent. But any number can be written as the number over 1. Same thing here. I know that sine alpha is the opposite over the hypotenuse. And if there is no denominator, the hypotenuse must be 1. Because in a right triangle, all trig functions are ratios, including sine and cosine. So sine alpha is this over this. So it's x over 1. Now tangent is y over 1, the opposite leg over the adjacent leg. Therefore, I determine this as being the sum of the squares of these two, because it's the longest side. When it's the leg, then from the hypotenuse squared, I subtract the other leg squared. But when I have to determine the hypotenuse, I have to add the squares of the legs. Better?
Yeah.
Always stop me and ask. Okay, so can anyone dictate? First step here. And then plus.
Oh yeah, I wrote it wrong. Yeah.
Plus
X, Y, X, Y, and Y squared.
you could, because they have the same denominator, you could write them as xy plus the square root of 1 minus x squared over the square root of y squared plus 1. We do not need to rationalize this. The reason why I don't want to write anything behind the square root is because by mistake I may extend the square root on top of what follows. So as a rule, it's not a written rule. We don't like to write anything behind the square root or a root in general. So I reverse the order. Good. Do we need another?
That's it.
That's it. Yep. This is the expression of cosine alpha minus beta, given in this form. Okay. We need another? It's okay. Do we need another?
Yep.
Okay, please choose. You can choose numbers, because the next set is with numbers. The same idea, but with numbers, or variables. Is this a good review for the test? Yes?
Can we do 48?
Yes, 48. 48 is with numbers. So that should be easier.
Okay.
48. Cosine. Parentheses, sine inverse the square root of 3 over 2 plus cotangent inverse of the square root of 3. We can apply the same idea if you want, or we can find the answer. Because I know the angle between between negative pi over 2 and pi over 2, whose sine is the square root of 3 over 2. I know the angle. I can replace it. I know what this equals to. Now, if this would have been 16 over 17, I would have not known what angle that is. But I know the angle whose sine is the square root of 3 over 2.
5 or 6.
It's not, if it's a square root of, for sine, the square root of 3 over 2 is not, it's not the first angle. Because sine for the very top angle, the tiny one, is 1/2.
5 over 3.
5 over 3. Plus, now you could say, wait a minute, you want me to give you an angle whose cotangent is the square root of 3, but you haven't taught me that. Or we could say, you told me specifically not to learn that. I only have two options. So for cotangent of this small angle, cotangent is cosine over sine, I have the square root of 3 over 2 over 1/2. And when I flip, I get the square root of 3. So it must be the small angle. What about the big angle? Then I will have 1/2 over the square root of 3. 1/2 over the square root of 3 over 2. And when I flip, I have the square root of 3 in the denominator. So it cannot be the big angle. It must be the small angle. So what angle is that? Okay, is it, so no, don't say anything. Is this clear, first of all? This one is clear. Okay, so for cotangent, I have two options, right? For pi over 6, I have cosine pi over 6 over sine pi over 6, correct? Well, this one is the square root of 3 over 2, and this one is 1/2. When I flip 1/2, I get the square root of 3. Let's see the other one, for pi over 3. For pi over 3, cotangent pi over 3 will be cosine pi over 3 over sine pi over 3. But cosine pi over 3 is 1/2, and this one is the square root of 3 over 2. And when I flip, I get 1 over the square root of 3, which is a big trouble. I have to rationalize is the square root of 3 over 2. So it cannot be this one. Does it make sense now?
Yeah.
So then what is the angle that represents this? Only one angle. Pi over 6. Now how much is pi over 3 plus pi over 6? How much? It's 60 plus 30.
Yeah.
Yes. How much is cosine pi over 2? Exactly, because it's measured on the x-axis. Now if you choose 50, I cannot solve it like that. Because 50 and 49 have unknown angles. Do we want to choose one or the other? Is the concept clear here? All you have to do is create a ratio.
Yeah.
And you will figure out what that is, which angle it's coming from. Because I don't want you to memorize this. I'm only asking you to memorize those sine of a sum and the difference, cosine of a sum and difference of angles and tangents. Okay.
One question, why would we not, I know it's simpler just to let the pi do, why would we not use the sum?
Because I can add the angles and I know this, that I know cosine of 90. But if you say, I don't remember, okay. Let's say you are not adding these two. What will you write? You will write cosine pi over 3 times cosine pi over 6 minus sine pi over 3 times sine pi over 6, correct? If you don't observe or notice that this is 90. Okay, let's see what we get. Cosine pi over 3 is the bottom angle. Cosine pi over 3 is very good, 1/2. Okay, cosine pi over 6 minus sine pi over 3. It's not 1/2, right? It's the bottom angle. And sine pi over 6. Same thing. 1/2 times the square root of 3 over 2 minus the square root of 3 over 2 times 1/2. Same quantity, 0.
Yeah.
Good. So 49 or 50? Which one? You should do 49 and we should try 50. Well, but it's up to you.
Yeah, that's good.
50? Okay, so 50. Sine. And in parentheses we have cosine inverse of 2/3 minus tangent inverse of 1/2. First, I have to identify what am I asked. So once I look at this expression, I'll say, oh, I know. I'm asked to find sine of the difference of two angles, right? So the formula for, I have to write the formula first, because I don't know where to start. I don't know what to do first. I want to see what I'm looking for.
Right.
So I have to write the formula. And this is the correct order, which is sine alpha cosine beta minus beta cosine alpha. I caution you, with your book, for some reason, different books presented things differently. I prefer keeping, it's easier for me to remember the order sine, cosine, sine, cosine. Your book presents it as sine, cosine, reversed, cosine, sine. It's up to you. I'm fine with both. But it's, for me, it's easier to keep it in order. Sine, 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 sine. Sine, cosine, sine, cosine. But it doesn't matter. Okay. So now I know that I have to come up with 4 pieces. Good. So I start with this. Because I don't know. I don't know what this is. I don't know what angle that is. I have no idea what angle has cosine 2/3. No knowledge of that whatsoever. So I have cosine inverse of 2/3 equals alpha, which means very good. So there is a right triangle somewhere with an acute angle alpha. Fine. It does what? What does it say?
So the bottom is 2.
Awesome. Good. So I have to find the leg. And when I find the leg, it must be the hypotenuse squared minus the other leg squared.
Right.
So this hypotenuse squared is 9, minus the other leg squared is 4. 9 minus 4 is, so this must be the square root of 5. So then I have 2 pieces of information already in the formula. What do I have? So I have sine alpha. What is sine alpha? And I have cosine alpha. So now I go back to the other angle, which is angle beta. So I have tangent inverse of 1/2 is angle beta. And then from here I have tangent beta equals 1/2. So there exists another right triangle with an acute angle beta. And what do I know about it? Yes. So the opposite is, yes, the adjacent is. And now I'm determining the longest side, which means 1 squared plus 2 squared, which is
5.
but with a square root. Good. Okay, so sine beta, please.
Oh, okay. 1 over 5.
Cosine beta, please. And now I'm expecting anyone to give me the form to write. Let's write it, don't simplify it just yet, so for everyone to see, and then we'll simplify it. The square root of 5 over 3 times 2 over the square root of 5 minus yes, times 2 over 3. Now, when we look at these 2 expressions, you may be tempted to simplify the square root of 5. I don't recommend it. Because if you don't simplify, you see the same denominator. So, in this case, I will write the least common denominator is 3 the square root of 5. And I will write the top as 2 to the square root of 5 minus 2. And that is the simplified form. Any questions?
Process.
Okay, I would like to look at a problem and I would like you to choose. I did not do this just yet. This is new. 55 through 58. This is new. We'll choose 2 different problems and I'll walk you through the first one and to the second one. Let's start with something simple. 56, okay. 56 says sine x plus cosine x. And here's the question. There is a formula in the book, but I don't want more formulas. I want to show you the mechanism. If you want to memorize the formula, you can. Write the expression in terms of sine only. So this is really asking us to write sine, don't write this, I'm going to erase it, of something. That's what it says. I just need, this is not the answer, but I wanted to just show you what we're trying to do. So, I only know a formula for sine of something with plus in it. Right, but I cannot use it just yet. Why? Because if I write here x plus y, then I have sine x cosine y plus sine y cosine x. So something is missing. Before I get here, something is missing, but yes, that's the idea. So I am thinking of sine of a quantity plus another quantity. I cannot use these letters yet. Okay.
Looks like we need to cancel out.
Or put in something. Awesome. Very good. Okay, here's the idea. I'm telling you that I have $4. You're going to say, good for you. And I'm going to do this. I'm going to multiply it by 10 and divide it by 10. And I'm going to tell you, I have 4 multiplied by 10 divided by $10. What will you say? Because you multiply top and bottom by the same quantity.
Yeah.
This is what I'm going to do now. So to sine x plus cosine x, I want to multiply it by a quantity and divide it, of course, by the same quantity because I'm not allowed to change the expression. But the question is, what do I multiply and divide by that is identical, that eventually I will distribute it in here, and I get sine cosine plus sine cosine to get my sine. Nope. There is only one quantity that is identical for sine and cosine. Just one. For one particular angle, there is one number that is true for both sine and cosine. Exactly. That's exactly what I need. Stay with me, it's not done. You understand that if I multiply the top by the square root of 2 over 2 and multiply the bottom by the square root of 2 over 2, I still have the quantity sine x plus cosine x.
Yeah.
Okay, now allow me to distribute the top. So I will distribute the top as the square root of 2 sine x plus the square root of 2 cosine x. The bottom cannot go away, otherwise I change the problem. And now please tell me, what do I replace this quantity by? And what do I replace this quantity by? So that eventually I get this to be a sine of an angle plus another angle.
Cosine x.
Which one? Careful. Which of these two? You're right. Exactly. I want the first one to be cosine, and I cannot change it. What is it? Cosine of what? No discussion.
X. No, y, sorry.
None of the above. Cosine of what is the square root of 2 over 2? Not x, not y.
Pi over 4.
Aha!
Oh,
Awesome. And what do I replace this by?
sine pi over 4.
Exactly. So here's what I have. I have sine x cosine pi over 4 plus sine pi over 4 cosine x over the square root of 2 over 2. What do I replace the top by? All this. Yes?
X plus pi over 2. Pi over 4, sorry.
That's it.
Yes.
And yes, I have to deal with the square root of 2 over 2 a little bit and simplify that a little bit in the denominator. Do you understand the mechanism? That pi over 4 was the only quantity that I could think of, because I had to have both numbers the same. Because I cannot distribute something to sine and something else to cosine. It has to be the same number. And that is the only angle that does that. Pi over 4. Because that's the only angle whose sine and cosine are the same. So now I will flip this, of course, into 2 over the square root of 2 times sine x plus pi over 4. And I have to rationalize. And when I rationalize, multiplying by the square root of 2 over the square root of 2, 2 the square root of 2 over the square root of 2. I shouldn't write it like this, sorry. So 2 over the square root of 2 multiplied by the square root of 2 over the square root of 2 times sine x plus pi over 4. These 2 will go away. This is a 2 and this is a 2. So the simplified form is this. And we accomplished our task. We started with sine x plus cosine x. And we got an expression in sine alone. Will this be useful? Very. When we get to trig equations. Although we are not going to really look at those super sophisticated ones. That's what my department decided.
Okay, now, the paper does that. I didn't write it. That's what I followed.
So are the steps clear? So how did I do this? I said 4 is the same with 10, 4 times 10 over 10, because these are simplifiable, right? So we thought of one quantity that once I distributed to these two will give me sine and cosine as well. And this is the only number. So we distributed the square root of 2 over 2 to both. And then I said, okay, how do I get a sine out of all this? Only if this one gets replaced by cosine pi over 4. So I get sine cosine plus. And if this one gets replaced by sine pi over 4, so I get sine cosine. So that then I apply the formula, because if I go back, I can check. Sine x cosine pi over 4 plus sine pi over 4 cosine x. So these are the same. This is the identity. This equals this. And then all I had to do is just clear that square root of 2 over 2. Okay, let's choose one more. If you allow me to choose, I will choose 55. Or 58. 57 is good too. Please choose.
5.
Okay. So we want to look at 55. Negative the square root of 3 times sine x plus cosine x. Okay, so I come to you now and I say, I have $4. But $4 is the same with $4 over 1. And then now I'll say to you, I have $4 divided by 2 over 1 over 2. In other words, I divided the top by 2 and I divided the bottom by 2. How much money do I have now? Still 4. This is what I'm going to do now. Why? Because I have a 1 here. The numbers are different. I can no longer use cosine or sine of pi over 4. So I have a 1 here, and I have a square root of 3 here. So then what should I do? So this is, again, like my 4 or 4 over 1. What should I divide the top by and the bottom by? Think in terms of those 3 numbers. I only know 1/2, the square root of 3 over 2, and I cannot use the square root of 2 over 2 because the numbers are not the same. So what should I divide the top and the bottom by? Knowing 1/2 and the square root of 3 over 2, I don't know anything else. So I divide the top by, no. I have this, I'm only talking about the denominator now. I'm not talking about the numerator. So in order to get either 1/2 or the square root of 3 over 2, what should I divide the top and the bottom by? Exactly. That's why I even gave this example here. So I will divide the top by 2 and the bottom by 2.
Okay, so why did we do that?
Because I saw the square root of 3. And the square root of 3, that if it doesn't have a 2 in the denominator, I cannot use it. And I saw the 1. And if I don't have 1 over 2, I cannot use any angle.
That makes sense.
So I'm looking for the square root of 3 over 2 and the 1/2. Because I can no longer use, in this case, I cannot use the square root of 2 over 2.
Right.
Why?
Because there's no square root of 2.
Because there is a square root of 3 in there.
Right.
Good. So I'm allowed to divide top and bottom by 2. I didn't change anything. Good. So now, because there is a negative in here, I would like to reverse them. It doesn't matter. But it's better if we reverse them and keep the negative in the middle. Or you can say, no, I want to factor out negative. Fine.
No.
We can factor out negative. Maybe that's even easier. That's even easier. So which one? You tell me which route you want to. Factoring out -1 is the same thing. I'm just going to have a negative in front, which is fine. I have a square root of 2 here, which is fine too. And instead, I'm going to have a negative.
Becomes negative
Right.
square root of 3 sine x minus cosine.
Exactly. So I can have this. I will put one in parentheses, the square root of 3 over 2 sine x minus 1/2 cosine x over 1/2. I separated the fraction. Again, this is algebra. I separated the fraction into 2 fractions, and I also factored out -1.
No, it's not.
So now I'm going to flip this, remove it from here into -2. So tell me please, what will you replace this by? Remember, the answer must be in sign.
Yes.
So what do we replace this by, and what do we replace this by? So that the answer is sine cosine minus sine cosine. Yes, I need the cosine. So now which angle has cosine the square root of 3 over 2? The first one.
Pi over 6.
And 1/2. What will I replace 1/2 by? So I have sine, cosine, sine, cosine. Sine, it has to be the same angle, right? Is sine pi over 6 1/2?
Yeah.
Good. So now please dictate. What will you write in parentheses? And let's make sure we put it in the correct order so we don't make a mistake. What will you write? Sine x cosine
Pi over 6.
minus,
Sine pi over 6.
and now I have it. So this is -2 sine what? And now in parentheses. Yes? Yes? That's it. If you don't believe this, you can use the formula sine x cosine pi over 6 minus sine pi over 6 cosine x. Distribute -2 to those two terms. You will definitely get the original expression. Any questions? Yes? Any questions?
Yes, I have a question.
Yes?
So, I wanted to do the other way, but it's.
You want the reverse?
Yeah.
Okay, perfect. So the problem would be cosine x minus the square root of 3 sine x. And we will divide the top by 2 and the bottom by 2. You understand that I cannot just decide to divide by 2 the top without dividing the bottom.
No,
Because, no, I'm not saying you didn't, but I just want to emphasize. So if I say to you, I have $4, and I decide to divide $4 by 2 without dividing the denominator by 2, then I no longer have 4. But if I divide the top by 2 and the bottom by 2, then I still have 4. Because when I flip, the 2 will go away. Okay, perfect. So now we want to write cosine minus the square root of 3 sine x. Perfect. Good.
so I had 1/2.
So now the expression will be, yes, 1/2 cosine x minus the square root of 3 over 2 sine x. Perfect. Good.
Then I had.
So this one now has to be a sine
Oh.
because it's sine cosine. And this one now has to be a cosine minus sine
No, I
cosine.
had that part.
So what is this?
So I had.
So this must be sine.
5 over 6.
Good.
And then I had the other one was cosine 5 over 6.
Very good. So then I have sine pi over 6 cosine x minus
Sine x. Cosine.
sine x cosine pi over 6 divided by 1/2. Good. Awesome. So now the top.
So then I had
Sine. Yes.
x minus.
Careful.
Not minus.
Careful.
Pi over 6 minus x.
Perfect. Pi over 6 minus x divided by 1/2. So this is twice sine pi over 6 minus x. And now to sine. Inside sine, I have to factor out -1
Do you have to? Do you leave it?
because I need to show that it's the same answer. I need to show that it's the same answer. We already have an answer, which is not the same with this. This is the correct order. We normally don't say sine pi over 6 minus x. We normally say x minus pi over 6. But it's not wrong. Okay, so then this is not the same, right? I need to show now that they are the same. So I factor out -1, what is left in parentheses here. And now I have to dig deep and ask myself, sine of a negative angle is sine odd or even? So this is sine of negative alpha. Sine of negative alpha is sine even, then it equals sine alpha. If a sine is odd, then it equals negative sine alpha. So is sine odd or even? There are only two even trig functions. It's an odd function. So then 2 sine negative alpha will equal 2 sine x minus pi over 6. And now we show that they are the same. It's not wrong, even if you leave it like this. But since we already got a different answer, I needed to show you how we get to the same thing. Any questions?
Does the order in the parentheses matter? What I mean by that is, does it have to be?
Yes.
Well, I'm saying, does the
So
x
this
have to
one-
come first?
This one is sine pi over 6 cosine x minus sine x cosine pi over 6. This one is sine x cosine pi over 6 minus sine pi over 6 cosine x.
Well, what I mean is, does it have to be in the form x minus pi over 6?
No, that's what I said. This is a perfect answer. But since 3 minutes before we got a different answer, I had to show you how to get from one to the other and why they are the same. Okay. We have 5 minutes. Let's not start 7.3 and just choose another problem to work on. If you want another one like this, or an identity, or anything else. Yes, let's choose.
41.
41.
Don't.
Where are you, 41? Yes, it's a good pick. Very good pick. So we have sine x plus y plus z. And they say that equals sine x cosine y cosine z, sine x cosine y cosine z plus cosine x sine y cosine z cosine x sine y cosine z, correct, plus cosine x cosine y sine z plus it's minus, sorry, minus sine x sine y sine z. Very good. Good pick. So, where do you think we should start? No, don't say the right hand side.
The left hand side.
Yes, yes. We will start with the left hand side. I just want to make sure. So we have 12 classes left. We're extending 10, so after this class we're down to 9. Okay. Yes, of course I will start with the left hand side. Although you can say, why don't you try to factor all these 4 terms, blah, blah, blah. It's possible. But I recommend the left-hand side, which is sine x plus y plus z. And I will say, if you say to me, well, we haven't talked about sine of a sum of 3 angles.
Yes.
We only know sum of 2 angles.
Yes.
No problem. I am going to call this angle 2. And I'm going to call this angle 1. And I will apply the formula twice. And I'll get all those terms. So, sine first plus second is sine first times cosine of the second plus sine of the second times cosine of the first. And now when I replace these two, I'll get all those terms.
Gotcha.
It's a good pick. So I replace cosine y plus z by, can anyone give us the formula? This is the one with cosine, cosine, sine, sine. Cosine y, cosine z minus
Sine y.
sine y times sine z plus, and now I have sine y plus z, so this will be
Sine y cosine.
sine 1 cosine z plus sine z
Cosine y.
cosine y, and I have to distribute cosine x. And once I distribute now sine to those two terms and cosine to these two terms, I'll get all those four. So, sine x, cosine y, cosine z. Do I have a sine x, cosine y, cosine z? Yes, right here. And then minus sine x, sine y, sine z. Do I have this? Yes, right here. Plus sine y, cosine z, cosine x. Sine y, cosine z, cosine x. Yes, right here. And the last one plus sine z, cosine y, cosine x, sine z, cosine y, cosine x, and it's exactly the right-hand side. I was kidding before. Yes, you could try to pair them and factor by grouping, but I think it would be maybe longer than to simply